Something remarkable just happened inside a California factory, and it changes everything about how humanoid robots get built. Figure AI just pulled off what most robotics companies said would take years. They scaled production from 1 robot per day to 1 robot every single hour. That is a 24 times increase achieved in less than 4 months. This is industrial revolution speed happening right now. So, let's go through Figure AI's factory process. The factory is called BotQ. It sits in Sunnyvale, California, and it represents the kind of manufacturing breakthrough that separates actual robotics companies from slide decks with venture funding. Over 350 Figure 3 humanoid robots have rolled off these production lines. Each one survived over 80 functional tests, including stress sessions where robots perform squats, shoulder presses, and jogging at cycle counts in the thousands to replicate real-world use and eliminate early failures. CEO Brett Adcock confirmed the company is on track to manufacture 55 humanoid robots this week. Let that number sink in. 55 complete humanoid robots in 7 days. This is no longer prototype territory. This is mass production. BotQ transitioned from prototype phase to production phase with dedicated lines for all critical modules of the Figure 03 system. The facility demonstrated the 1 robot per hour cycle time needed for production targets. The scale-up was made possible by developing efficient lines powered by custom-built manufacturing execution software running across over 150 networked workstations. The largest fundamental challenge was improving yield rate and cycle times. Figure drastically improved quality at the supplier level by qualifying hundreds of suppliers against incoming inspection criteria to ensure only good parts make it into the building. Every step of the build process has quality checks along the way, with more than 50 in-process inspection points making sure only good sub-assemblies roll through the lines. The rigorous focus is already paying off. End-of-line first-pass yield is now over 80% and improving weekly. The battery line achieved a 99.3% first-pass yield and shipped over 500 battery packs. The facility has produced over 9,000 actuators across more than 10 distinct SKUs. Actuators are essentially the muscles of the robot, enabling movement and precision. Scaling that part of production is a major step toward building robots in meaningful volumes. Each robot undergoes over 80 functional verification tests before sign-off. This includes multi-limb stress testing and comprehensive burn-in sessions where robots perform full-body exercises such as squatting, shoulder presses, and jogging at cycle counts in the thousands. This testing replicates real-world use and eliminates early cycle failures before robots ever leave the factory. Faster production equals more robots in the real world. Companies like warehouses, logistics firms, and manufacturers are waiting for these machines. The faster Figure builds them, the sooner they can replace repetitive human jobs. Robots shipped from BotQ are allocated to internal research and development groups, data collection, efforts for robots to perform end-to-end housework, and commercial use case development. The larger the fleet becomes, the more data Figure generates for Helix, its humanoid AI model. This growth also allows deployment of more robots into the real world, where direct feedback from live operating environments hardens the system and capabilities. By running more robots for longer duration, Figure has encountered and resolved failures that were invisible at smaller scale. This influx of real-world data enabled the company to build robust diagnostics. Figure implemented an advanced alert system and diagnostics for failure analysis, allowing them to pinpoint the root cause of an issue in minutes. Engineers developed software fallback ladders that allow a robot to gracefully degrade its performance or safely recover from a non-critical fault, keeping the use case running. Having already addressed high-frequency hardware and software issues, focus has shifted to the long tail of edge case failures, a stage of maturity that only comes with significant fleet hours. To sustain this expanding fleet, Figure is aggressively scaling its service and support infrastructure. The company developed its own internal field service management system and the tooling needed to service Figure 03 in diverse environments from headquarters to customer sites to residential homes. This service loop is a critical feedback mechanism. Field failures are tracked, analyzed, and fed back to the engineering team for hardware revisions. Figure established rigorous processes for fleet-wide upgrades and recall campaigns, ensuring every robot in the field stays current with latest engineering standards. The company built a custom fleet management system that coordinates robots autonomously across various use cases while tracking real-time health, location, and operational status. Combined with over-the-air software update infrastructure, Figure can now deploy new behaviors and upgrades to the entire fleet simultaneously. Figure is not alone in this race. Tesla, Boston Dynamics, Unitree, and other companies are also racing to build humanoid robots. This is a competition with billions of dollars on the line. Whoever dominates the robot workforce market could reshape the global economy. Figure revealed plans for the BotQ facility last year, targeting 12,000 units annually with plans to scale production further. The company switched to tooled processes such as injection molding, die casting, metal injection molding, and stamping, which enabled them to save thousands of hours on manufacturing. Parts that previously spent over a week on a CNC machine can now be manufactured in under 20 seconds with complex steel molds. Switching to these processes comes with high capital cost, but the upfront investment is made back quickly when considering robot volumes for 2025 and beyond. Figure also introduced a major upgrade to its AI model Helix System 0. Previously, the model relied solely on proprioception, understanding joint states and body motion, limiting its ability to navigate complex environments like stairs or uneven terrain. With the latest update, System 0 now integrates visual input from onboard stereo cameras, converting RGB images into a three-dimensional spatial representation of the surroundings. This allows the robot to both feel and see the terrain it navigates. The system is trained end-to-end using reinforcement learning in simulation across diverse randomized terrains. The learned behaviors transfer directly to real-world environments without additional calibration or fine-tuning, overcoming a long-standing sim-to-real challenge. Robots can now traverse stairs and varied surfaces with human-like stability and motion, even under changing lighting conditions. What System 0 learns in simulation is what it does on hardware, with the same human-like gait and recovery characteristics it exhibited on flat ground. Stair traversal is only the first use case. The same architecture, perception in and whole body control out, trained in simulation and deployed zero-shot, allows access to a much broader class of behaviors, where the scene around the robot matters. Some people think this is amazing. Robots can do dangerous jobs, handle repetitive tasks, work without breaks. Others fear job loss. Will robots replace humans? How fast is too fast? Are we ready for this future? Figure was founded in 2022 by Brett Adcock, also known for founding Archer Aviation and Vettery. The company introduced its prototype Figure 01 that year, a bipedal robot designed for manual labor, initially targeting logistics and warehousing sectors. In February 2024, Figure secured $675 million in venture capital funding from a consortium including Jeff Bezos, Microsoft, Nvidia, Intel, and the startup funding divisions of Amazon and OpenAI. The company was then valued at $2.6 billion. As of late 2025, its estimated value reached $39 billion.